Welcome to the video on extracting line item adjustments, video 3. This is part of a 4-part video series. I'm David Braun from Automated Valuation Technologies. You can contact me at my email. You can also go to my website and see more videos on regression analysis and other statistical techniques. If you'd like to be contacted in the future concerning future offerings, please send me an email with future offerings in the subject line. I'll be sure and get you on the email list for notifications. Video 3 is an intermediate level video. It's for intermediate level appraisers in statistics. The first 2 videos were definitely for people beginning with regression analysis. Now that you're including your analysis part, your regression analysis part of your appraisal, be sure and have something in your qualifications that you could send to your clients, or that you might just include in your appraisal report so they understand why you have competency in this. Now, there are a number of related advanced level techniques that are not identified and discussed in this material. This is intermediate material. We're not going to discuss things like log conversions, ridge regression, variation inflation factors. We'll leave that for more of an advanced series. All right, what's our number one goal when we talk about extracting line item adjustments and how much due diligence we should apply? I think about USPAP compliance. Now, I'm a certified USPAP instructor and have been very involved with USPAP, and I believe it's what we want to use as our guidelines. Fannie Mae or secondary market has some guidelines. Each individual AMC may have some guidelines, but in this video, I'm concerned with USPAP compliance. Now let's talk about, I'm just going to give you some references here because this is not a USPAP class, but Standard Rule 1-4, Standard Rule 1 is the development of the appraisal. And if you'll go to lines in your USPAP book, when you have time, to 582 through 585, it talks about the appraiser's responsibility to use analysis and in making their decisions, such as extracting line item adjustment rates would be one type of a thing. Standard Rule 2 has more to do with Standard Rule 2 is to do with reporting. Standard Rule 2A is the appraisal report as opposed to a restricted report. Secondary market work is, of course, an appraisal report. You might look at line 726 through 734, and it talks about the responsibility of the appraiser to report the analysis and to explain how the analysis works. So not really how it works, but how the analysis was relied on in order to come up with a conclusion. Now, I'm more interested in us focusing on in the scope of work rule, there's lines 402 through 403, and we'll jump to that. It says, credible assignment results require support by relevant evidence and logic. So to meet USPAP, when you make a decision such as extracting a line item adjustment rate, what you're going to use to adjust, say, for gross living area, it should be based on evidence and logic. Now, this is really basic stuff, but it's very important information. Now, I developed a seminar called Fundamental Concepts of Analysis. It's a 7-hour CE virtual seminar for the McKissick School, and it is specifically about what is a decision. Why do we analyze? What data should we use? When do we have enough evidence? How can we measure evidence? At what probability rate? And so it's very basic. It stays to the very basic and heart of making decisions. So if you haven't taken that yet, then get that on your list to take. you're ready for it. If you understand what we're doing in this seminar, you're ready for that. I say seminar, but in this video. All right, evidence and logic. Let's think about it. We can get evidence by direct market extraction. We can get it by indirect market extraction, and that's a lot of the fundamentals of supply and demand. When we can't get it directly, we can look at what supply and demand is doing in our area, and we can infer we can infer some evidence. Those inferences become evidence. Also, we can make some decisions based on acceptable economic principles. Those principles are like the diminishing rate of return, scarcity, change, and balance. So sometimes we try direct, we can't do it. We do indirect, we get a little bit of information, and then we also couple that with the logic of the accepted economic principles, and that's our evidence. Now, what about common sense? Common sense, I think, is acceptable when none of the others work. Now let's talk about experience and common sense. They're really two different things. Experience is great, but experience is based on something that happened. It's a fact that happened. So if the appraiser states the things that happened, the facts that happened, when they happened, and how they relate to the decision at hand, then the experience actually goes back up, and now it's going to either be direct market extraction or indirect market extraction. So we don't have anything against the appraiser using their experience, but experience is not something you reach into a black box and pull something out and say, here it is. I can't explain how it got there. It's my experience. No, your experience are facts, so there is no black box. So we're not against experience. It's just that we don't call it experience. We call it all direct market extraction or indirect or based on acceptable principles. So we're doing away with the term experience, but we can use experience. Common sense is applying logic to an incomplete data set. Some adjustments in some markets can't be directly or indirectly extracted from the market. Everybody knows this. But you still have to explain your reasoning regarding the adjustment you did or didn't make. And I would suggest you tell what you tried to do so they know you didn't just slap something out there, that you really tried to find it. Now, what is regression analysis? Regression analysis is a direct market extraction method. All right, what's the problem? What are the culprits, or what can interfere with multiple linear regression analysis when extracting line item adjustment rates? Now remember, we differentiate between regression analysis to find value, simply to find value, and regression analysis for some other things like extracting line item adjustment rates. Okay, now here we're talking about regression analysis when extracting line item adjustment rates. So what can cause the regression analysis not to really be reasonable or accurate? Well, random variance. Random variance is what happens in the market that we can't control. It's also the data we use that's not accurate. It's when our model does not really represent the market, doesn't think the same way the market's behaving. And we measure that with our, by taking our sales price minus our predicted value, okay? We take our sales price minus our predicted value, and we get a residual. So when these residuals get big, the bigger they get, then it can interfere with us getting an accurate coefficient. Also, something that didn't involve finding a value at all, we've got to be concerned about collinearity and multicollinearity. So our goal is, in this seminar, is talk about how do we minimize these. All right, to minimize random variance, we want to use comps from the same market. So we don't want to desert our appraisal training. You know, if you throw comps from different markets on your appraisal grid, you're going to have issues. Well, it's the same way with regression. It's very important. The whole basic appraisal starts with identifying your market and pulling comps from the same market. So I did write a paper. It's at my website. It was also published in the Appraisal Journal. But you can go to my website and go to Activities and Articles, and you'll find it there under Market Delineation. It's very important that you use comps from the same market. So you need to understand what that is. All right, we want to use accurate data. That's important whether you're finding value or extracting sale adjustments, but line item adjustments, but we want to use accurate data. So you may want to take a little more time than usual to be sure your data is accurate. We might want to add a couple more variables. It's not necessary in regression, and we're going to see this later. It's not necessary in regression to have every variable included. If there's 15 things that have a relationship with sales price or value, we may still be okay, but instead of using just 3 or 4 things like we were able to do to find values, we may want to use 5 or 6 things, but we don't have to use all 15 of them. If you remember in the last video, we pretty well accurately trended values over time over a 6-year period, I think using just 4 property characteristics or variables. We also want to use contrasting data. Each coefficient should be based on many hits. Now what that means is if you're trying to extract a in-ground pool adjustment and you have 20 sales with no pool and 2 sales with pools, that may not be enough hits, or you may not have enough sales that had pools. So it's important to have many hits. And that gets into how many sales do you need. You know, if you're extracting a certain adjustment, you're going to have enough sales that you have a lot of hits for that particular property characteristic. And we might try to address and minimize our curvilinear relationships, and we can do that with logs, but in what we talk about in intermediate, usually we just shave off and we try to use only the data that's not in the diminishing rate of return curve or whatever the curve happens to be. But we might address that. Usually a curvilinear relationship only affects 2 or 3%, but that's still a variance that maybe we can get rid of. All right, try to match the actual market behavior to the model. Okay, sometimes we try to put a round peg in a square hole. Now, let's talk about bedrooms and baths just a minute. I know back when I started using regression several years ago, I found that it very seldom returned my bedroom adjustment or my bathroom adjustment, especially when it was detached housing market. Now, I would get them sometimes if I was doing apartments, especially if I was using regression to find market rent for an apartment. Bedrooms, apparently, the market looks at bedrooms and they look at baths. I think also in attached housing, sometimes it works. So you have to always try it. You want to always put your bedroom and bath in. But let's talk about why maybe we don't get it returned. Now, I can think of 3 reasons, and if somebody can think of a 4th or 5th reason, I'd love for you to send them to me so I can get it in my notes. But often, the number 1 reason, there may not be enough contrast or enough hits for the bedrooms. When you look at your bedrooms, if they're all 3 bedrooms and you have 2 2-bedrooms and 1 4-bedroom, probably don't have enough hits, so it can't read it. Doesn't mean it's not there, it just means the regression can't sort it out. Also, bedrooms sometimes could be correlated, could have a correlation with gross living area. In other words, they're both measuring the size of the house. And if that gets to a point that the regression gets confused on what value is changing from the bedrooms and what value is changing from the gross living area, excuse me, then that's collinearity, and that can be an issue. Usually you can find that by just clicking and unclicking these 2, and if their coefficients change drastically, that could be the issue. But there's also a 3rd possibility. It may be that the market doesn't really value bedrooms and baths on a per unit basis. They either see them as adequate or not. So it could be a variable, and we could begin right here, because I've never read this in a book anywhere, that there's a new category of variables called adequate or not. In other words, they're important, but it's just important that they're adequate. So you just want to make sure your sales selection only uses adequate comps that have adequate bedrooms and adequate baths, if that's the case. But the whole point of being a valuation analyst is that you know these possibilities, you think through them, and then you make a decision on what you think it is. So if, for example, if a market isn't counting per units for a bedroom value and you force it to, you say, well, I'm going to make it count 8,000 for that, you could have additional market variance that you don't want. All right, minimize random variance. One thing don't do not simply use the outlier delete button. Now, some of you may not have that, but you can find the one that has the greatest residual or residual as a percentage of the original sales price. And the ones that worse, a lot of people just begin to delete those out. And what will happen is after the true outliers are removed, you will only be removing the contrasting data. Now, this is going to diminish the robustness of the model, so you don't want to do that. Get rid of your outliers, but don't start just deleting sales to get the variance down, because that just is going to hurt you as well as help you. Okay, now the reality is that no matter how tidy you make your model, it will not change the inefficiencies of the actual market. So no need to do it. All right, how do we minimize collinearity? Well, first of all, what are we talking about? First of all, that relates strongly to the assumption of independence. If each property, and what we mean is each property characteristic being independent of all the other property characteristics. Now, if in real property markets, each property characteristic was 100% independent of the other property characteristics as far as value is concerned. If they were 100% and they were 100% just independent of each other, it would be very easy to use regression in real property appraising. You could use just simple regression and it would work every time. The truth of the matter is, real estate markets property characteristics are seldom independent. Usually the bigger houses have more bedrooms. The houses with more bedrooms have more baths. And sometimes the more expensive homes have a higher degree of quality. So we have issues. This is one of the things that really works against us in appraising using regression analysis to extract sales, is that our property characteristics are seldom independent of each other. Okay, now would we minimize the collinearity? Well, we wouldn't use multiple variables that measure the same thing at one time. If the regression analysis thinks that bedrooms and gross living area are measuring the same thing, you have to turn one of them off. Okay, so you have to kind of get a feel for the model, and you'd have to turn one of them off. You could run a correlation matrix prior to running the regression analysis to look for property characteristics that are very correlated with each other, so you're aware to try to turn one of them off and see how it works. But be aware that a correlation matrix will not typically identify multi-collinearity. And collinearity is when two things kind of run together on one regression line and the regression can't figure it out. Multi-collinearity is when there's more than two things. All right, now the simple fact is, on an intermediate level, and sometimes even at an advanced level analysis, collinearity may make extraction of some line item adjustments impossible. You may run it and just say, can't get it, didn't work. I would still report that in your appraisal, because a lot of times clients, state appraisal commissions, reviewers are all looking to see, did you try? You know, they're looking to see, did you do your due diligence? So if you run something and it doesn't work, it's still great to tell that you tried it. All right, how do you recognize collinearity? When coefficients appear to be absurd, okay, you can kind of trust your instincts. Appraisers know if the gross living area is returned at $10 a square foot, they know something's probably wrong with that. Maybe the garage has come back at $80,000 per parking space. You know right then something is wrong. So when you feel something is wrong, you've got to stop and try to get the model to work better, or you have to say, I tried, but it's just not going to work with this data set. when a large change in the coefficient results from adding or deleting a variable or adding or deleting a sale, an observation. So if you've got gross living area indicating $82 per square foot, that's what the coefficient is, and it's indicating that, and you unclick the garages and that jumps to 120, something may not be right. Same thing with turning a sale on and off. Look up at your coefficients and see how it changes. Also, a coefficient might have, that's got collinearity, the coefficients may have large standard errors. Now, that's not the standard error of the whole regression. It's just the standard error related to that one property characteristic. Now, so now you need to watch and be looking at your standard errors and see what they look like, so that eventually you can say, wow, that standard error is like 3 times what I usually see. Okay, so now you've got something that you can watch and work with. Now what we're going to do now, we're going to leave PowerPoint and we're going to perform 2 regression demonstrations. Let's introduce video 4 right here, which is converting the coefficient to a line item adjustment rate. Okay, so the question is the coefficient the line item adjustment rate? And a lot of times it's not. So in the next video, we're going to talk about how you take a good coefficient and make sure that you bring the right number to use in your adjustment grid. Now I know a lot of you say you watch this with the hopes that you could build better models, okay? And you say, David, you didn't cover everything I wanted you to. Well, one thing, this is a 30-minute video. I can't cover everything. 2, I'm not getting into a lot of the real advanced stuff because it just would be counterproductive. However, this might be a good time to watch the webinar, Why Bad Things Happen to Good Appraisers. It's at the Appraisal Institute site. It's probably a 90-minute webinar. Dr. Ken Lush put it on. He's an appraiser as well as a PhD. And that goes into some other issues related to this seminar. So there's really no need for me to repeat everything he put in that seminar. All right, now let's get to our analysis here. Here we go. Okay, now I have some data here. Now this is like market modeling, because what I've done is I've made a virtual market. In other words, we've got sales price, date, gross living area, bedroom, bath, and age, but I've made these up. Okay, that's why it's virtual. It's not a real market. I made it up because I wanted to have specific circumstance. So let's look at this. Our sales price is based on the coefficient. Here are the coefficients for each thing up here. Gross living area, $10,000 times the size plus, $100 a square foot times the gross living area, $10,000 times the number of bedrooms plus $5,000 times the number of baths plus a minus $3,000 times the age. Okay, and you can look at this formula. It's up here in the formula bar. And one thing I notice is that column D is not included in this. Okay, column D has no effect on the sales price. So basically, the way I've built this, there's no relationship between the date and the sales price. Now, when the date of sale has no relationship with the sales prices, that's our definition of a stable market. So we know this is a stable market. We know it is. We made it. We built it. We've checked it. One other thing that's unusual about this is there's no random variance. You see, it's strictly these numbers times each other. There's no plus an error or a residual. There's no plus. So the random variance has nothing to do with what happens here. It's got to be something else. And I'll give you a hint. It's going to be collinearity, because those are the 2 things we identified, right? So what I'm going to do is I'm going to trend my sales price against my dates and try to get a trend in value. Now, I want my date to be over here in front of sales price, so I'm going to move over here, and now my date's to the left and my sales price is here. Now I'm going to make a chart. I need to open up. Looks like I need to, no, not auto hide the ribbon. There we go. Show our tabs. Always happens on a video. I get stuck. Okay, so now we want to go to Insert, Scatter Chart. Now I am going to insert a trend line, add a trend line, and I want it to be linear. And let's make it where we can see it. I'm going to make it red, and I'm going to make it a line, and I'm going to make it maybe a little bit bigger. Maybe we don't need it much bigger. Okay, I'll close this. Now that represents the trend in values over time, but I have an issue here because that doesn't look like stable. That's showing an increase. Okay, matter of fact, it's showing like a 58% increase over a year. Well, something's wrong here. Okay, now what kind of analysis is this, first of all? Well, it's a regression analysis because, now it's simple regression because we used one property characteristic, in this case the date, or transactional characteristic in this case, with the sales price. We only used one. So it's simple regression. What makes it regression? Well, these plots are all, these sales are all over here. And if you go to your Excel and look it up, Excel inserts a linear line, a straight line, based on the sum of the least squares method. So basically this is regression analysis. So we're using simple regression and it's just all wrong. Okay, now why is it wrong? Well, we're going to go over here. Here's a correlation matrix. You should be able to make these. If you can't, you need to make a note. Learn how to make a correlation matrix. And I've already highlighted, just to kind of cheat a little bit to move the video along, is that date and gross living area are highly correlated. Okay, because you can only be from a -1 to a 1, so it's very close to a 1, so these are highly correlated. Now let's go to our data and let's look at our date and our gross living areas. We can see early on, now these dates are in chronological order going down, and we can see that early on there's a lot of these are 1400, 1350, 1375. We get down here in the middle, we see 1500, 1800, 1900, 2200. We get down near the end, we see 2400, a lot of 2400s. So we don't need a fancy statistical correlation matrix to tell us that as time went by, just happened that the gross living areas got bigger, the houses were bigger. So what's happened here is that correlation caused the gross living area and the date of sale to kind of move on to one regression line instead of having their own. They kind of collineated, collinearity. They kind of co-moved on to the one line, and regression can't read which is which anymore. Now, when your model can't read it, then that's when collinearity happens. Okay. Well, you can have sometimes correlation. It doesn't affect the model. The model can still read things. Then it's not collinearity. That's kind of the definition of collinearity, when it begins to interfere with your model. So I guess the main thing is be careful anytime you use simple regression on property markets that are not particularly homogeneous. If they're not homogeneous, you wouldn't use them. All right, let's go to our second example. Now we're going to look at something that has to do more with the power of regression. Now, this is real data. This is not made up data. This is not a virtual market. This is real data. And we're looking at the sales price, sold date, gross living area, age, bedroom, baths, basement. Now, what I notice is there's no lot here. Okay? There's no lot in here. Now, I know the lots in this area are about 30,000. So what I'm curious about is maybe we should adjust our sales price down 30,000 so we can get better line item adjustment rates, better coefficients. Let's see if that's true. So let's take this data and let's go open up our regression program. I'll move this over, bring it in from the clipboard. All right, now we're going to calculate. We got sold date, but let's use, I think for the date I've been using January 25th. We'll use that. All right, now we want to use sales price. All right, now what I want you to do, I can see my I know to get rid of my bedrooms and baths. All my p-values look good. My coefficients look good. I want you to write down the value, all of the coefficients. So you got the intercept, the gross living area, age, basement, and the decent sale. So if you'll write those down, you can hit pause if you need to. Okay. Now, what I want to do is go back to my regression. And let's look at bringing in a different sales price. Well, I've already got it made over here. What I've got is, this is the same data, and I've got a column for sales price too, and we want it to be equal to all of the sales prices minus the approximate value of the lots, 30,000, because we want more accurate coefficients. Okay, so you see how we're getting this, because we want more accurate coefficients. So since lots are not included, we're wondering if maybe we should adjust our sales price. All right, let's take it over and see. All right, let's set our date back to the 25th of January. All right, now we don't want to find it based on sales price. We want to find this based on sales price 2, where sales price 2 is where we've adjusted, took out 30,000 for the lots, because we didn't consider that. And we want to turn off our bedrooms and baths, so we have exactly the same analysis with exactly the same data. We just lowered our sales price. Now, let's look at our value. Now, it looks like our value is about 30,000 less. That makes sense because we lowered it by 30. Let's look at our gross living area coefficient. It was 95. It's 95 now. That didn't change. Our age, that's the same. The coefficient for the basement, it's the same. The decent sale is the same. Wow. The coefficients didn't change. Now, the intercept change, it lowered by 30,000. So let's take a look. The moral of this story is don't adjust your sales prices to make up for the variables that you know are left out, because regression tries to put these on their own. Each of these individual property characteristics kind of has their own line in the regression analysis, and it looks like the coefficients stay true on those lines. Now, I'm sure we could make some kind of adjustments that would mess things up, but you can see basically what happens there. Now let's go to the Excel and let's take a look at the regression lines. Now this is the lines for each regression. It's not the lines for, I'm going to see if I can get this to show it all. Let's get to 75%. Okay, and then we'll even get rid of our ribbon. And now let's come up a little bit. Now, this is the regression line that puts them all together. This isn't the individual ones. But here's our first regression line, the red one. Okay, here it is. And then when we took off the 30,000 across the board on every sales price, it shifted the regression line down. If you come down here and across to where this starts to where this starts, or to where this ends and this ends, there's about 30,000 difference, because that's what we took off. So there probably is exactly 30,000 difference. But what I want you to notice is, this line and this line have the same slope. They have the same slope. And what you need to understand at this point, slopes are what involves your coefficients. Okay, so these have the same slopes. So that gives us an idea that the coefficients didn't change. Okay, so in this seminar, we've tried to isolate that we need to get rid of, if we want to extract line item adjustment rates, we need some hits. We need enough sales that we have plenty of hits for each property characteristic we're trying to extract. We understand two things that really can interfere with our analysis, and that is random variance, which is measured by the residuals, and also in extracting sales, collinearity and multicollinearity. We looked at ways to try to minimize the chance of them happening. We also recognize that sometimes there's nothing we can do. Sometimes they interfere so bad there's certain line item adjustment rates we won't be able to extract with regression, and when that happens, we'll just have to try it another way. All right, I'll try to get video 4 ready. So thank you for watching video 3.